guys. Today I'm gonna take you on a applied chemistry lesson, and the lesson is gonna be on carbon. So let's start.
Remember, carbon has 4 valence electrons, which means it could have 4 bonds. Knowing this, let's go over the 4 different ways a molecule can be represented. The first way is the typical molecular formula. The second way is the structural formula, which looks like a typical Lewis structure. The third way is called a condensed structural formula. To write this formula, we looked at the structural formula where on the first carbon to the left, there are 3 hydrogens attached. This is why we have CH3. Next, the middle carbon only has 2 hydrogens, so CH2. And the last carbon to the right has 3 hydrogens, so CH3. The fourth way is what you will most commonly see throughout the entire semester. It is the skeletal formula, also referred to as a line diagram, where each point represents a carbon and the hydrogens are not shown. This is where knowing that carbon wants 4 bonds is going to be very important. This is what the structure would look like if we drew in the hydrogens. At this carbon, we already have 1 bond, so we are missing 3 more bonds, which must be 3 hydrogens. Next, the middle carbon already has 2 bonds, so we need 2 more, so we have 2 hydrogens. And this last carbon already has 1 bond, so we need 3 more bonds, so 3 more hydrogens. To make sure you get, and we'll go over the answers together. Okay, here are the answers. The structural formula consists of 4 carbons and 10 hydrogens. So this first carbon needs 3 hydrogens. Next carbon has 2 bonds, so it needs 2 hydrogens. Same goes for this carbon. And this last carbon has 1 bond, so it needs 3 hydrogens. So this is our structural formula. Using the structural formula, we'll write the condensed structural formula, where this first carbon has 3 hydrogens, so CH3. The next carbon has 2 hydrogens, so CH2. Same for the next carbon, so CH2. And the last carbon has 3 hydrogens, so CH3. This is our condensed structural formula. Now for the skeletal formula. Since there are 4 carbons, we need 4 points. There is a trick to drawing this right each time. If you were to count 1, 2, 3, 4, we actually drew too many carbons. We drew 1, 2, 3, 4, 5, but we just wanted 4. So if you count to 1 less carbon than what you're originally looking for, then you will draw the correct amount of carbons each time. So in our case, we will count to 3 when drawing the lines. So 1, 2, 3. And we really have 1, 2, 3, 4 carbons. This is the correct skeletal formula. These molecules that we are working with are called hydrocarbons. A hydrocarbon consists of only hydrogens and carbons. There are different types of hydrocarbons. This is based on the type of bonds that are between the carbon atoms. Alkanes have single bonds. Alkenes have at least 1 double bond, and alkynes have at least 1 triple bond. You will later get into naming different types of structures, so know that the ending is very important. If something ends in -ane, it's an alkane, meaning it only has single bonds. The ending -ene means it's an alkene, which has a double bond, and the ending of -ine makes it an alkyne, which means it's a triple bond. This all is talking about the major carbon chain or longest carbon chain. But we can also have something known as a substituent, which is an atom or groups of atoms that replaces a hydrogen and gets attached to the carbon in the longest carbon chain. Think of it this way. The longest carbon chain is like the body of a person, and the substituents are the arms or legs, because that's what's sticking out of the body. Here's a list of the most common substituents you will first see. These specific substituents are also referred to as alkyl groups. An alkyl group is made up of only carbons and hydrogens. It is also defined as an alkane that is missing 1 hydrogen. The first alkyl group is methyl. This has only 1 carbon. Next is ethyl. This has 2 carbons. Then propyl has 3 carbons, and butyl has 4 carbons.